one of the pieces is going to be when x is less than -3. So I'm going to put a little highlighter up here. That's going to be right there. Not on the graph up there. I mean, it's going to be, if I were to put a box around it, in this yellow region. Isn't that yellow region where on the graph x is less than -3?
Yes.
Okay. What does this mean?
Less than or equal to.
Just in your own words. Between what two values? Between -3 and 4. On the graph, where am I going to graph that piece? Well, I'm going to graph it between -3 and 4. So let's see, that's -3 to 4. That's going to be graphed in this middle region. Okay, and how about the last piece? What does it say?
X is greater than 4.
So guess where I'm going to graph that?
Anywhere greater than 4.
So in this region over here. So I have 3 pieces of the graph, and that's where I'm going to graph them. Let's do this piece. This is f of x equals 2, or y equals 2. Would you make a horizontal line in the yellow region at 2? So here we go. And don't put any endpoints on it. I'll tell you in a second. Don't put any dots on it. This says this is a horizontal line at 2. Agreed? Okay. I'm only doing it here. I am going to put an arrow going this way and an open circle here. The reason why I did that is because this says x is graphed when x is less than -3. Does it include -3? No. So that's why we put an open circle. Okay. Let's do the next piece. The next piece is -2. So what kind of line is that? Y equals -2. What kind of line is that? Horizontal. At -2, so that's down here. And we're going to go from -3 to 4. Okay, so we're going to make a horizontal line at -2, and we're going to do it from -3 to 4. Okay, what kind of endpoints should I put on this line? Closed and closed. Because aren't they both or equal to? Okay, then last. F of x equals 4 from 4 on. So what kind of line is that? Y equals 4. That's what this means. F of x equals 4 means y equals 4. Still horizontal, right? But where is it? It's up at 4, and we're going to go from 4 on. So actually, even though I have to show that it goes forever. Okay, so I draw an arrow. And what kind of circle am I going to put on the endpoint? Open. Do you see the 3 pieces of the graph? Okay. So 3 pieces correspond with the 3 pieces. Okay. Now you might think, why do we have to do this? This is, you know, what? This actually does happen more so in real life than maybe some of the other functions we study. For instance, sometimes there's certain prices and they're at levels. Like maybe an item is $2 when it's between a certain weight, but then it's $4 when it's another weight. So this is something where a function just changes at different x values. You guys ready to try the next one? Too bad. All right. The first 2 pieces. Y equals 1. What kind of line is that? I hope you're catching on to this.
Horizontal.
Horizontal. This is going to be horizontal, and this is going to be the line y equals x. So we'll talk about that in a second. The line y equals x has a y-intercept of 0 and a slope of 1. Alright, so let's do our pieces again. This is going to be graphed when x is less than or equal to 1. So let's put some labels on our graph a second. Those are negatives. Okay. When x is less than or equal to 1, that means this way, right? Okay. How about from 1 to 6? That would be, here's 1 to 6. And then from 6, greater than 6 is just going to be, I'm putting arrows so we understand that that goes forever. Okay. Okay. So you guys tell me, this piece, how should I draw it? It's a, what kind of a line? Horizontal line at 1. Okay, so I'm going to do a horizontal line at 1 all the way to when x equals 1. Okay, what kind of circle am I going to put? A closed circle. And I draw an arrow just to say that that's going to go forever to the left. What's my next piece going to look like? My next piece is, so it's a, what kind of a line? Horizontal line at 2. So it's up here, and I'm going to go from 1 to 6. So now we just have to decide about the circle. Open and close. Very nice. Okay. Just when it was starting to get easy, we throw a wrench in it. X. What's X? Okay. If I said graph, what this means is this is like y equals. This is y equals x. Okay, help me out, guys. Doesn't y equals x have a y-intercept of 0 and a slope of?
1 negative. Or negative 1.
Just 1. Because it's not absolute value. That's what you were thinking of, okay? Just 1. Now, here's what I'm going to do. I am going to start graphing it, but I'm not going to start drawing the graph till after 6. Ready? Put your pen on 0, 0. Don't make any marks. Because the y-intercept is 0. Now what should I do? Go up 1 over 1 until we get to 6. Here we go. Up 1 over 1. Up 1 over 1. Up! Up 1 over 1. I know we're going off the grid. Oh, crapola. 0, 1, 2, 3, 4, 5, 6. 1, 1, 1, 1, 1. Yeah, thank you. Jolly Rancher for you. Okay. Hold on, I need, oh, some student took my white out during academic advising today and they didn't give it back. Okay. Alright, so now the pieces are horizontal, horizontal. Oh, shoot. What kind of circle should this have been? Open. Circle there. Alright. Let's try one more. One more. Alright. This one, we only have 2 pieces. That's why we can try it and it won't be so bad. We have when x is less than 0. Okay, isn't that over here then? And then we have when x is greater than or equal to 0. What's the boundary line then? The what axis? The y-axis.
Yep.
Okay, so here's what we're going to do. We're going to graph this kind of line when it's negative, and we're going to graph this kind of line when it's positive. Okay, let's do the positive one first, okay? It's 2x. You guys tell me, what's the y-intercept?
2. Wait.
Oh no. What's the y-intercept? There's nothing there, so it's 0. What's the slope? 2. So, we're going to start it at 0. Perfect. We're going to put our pen here. We are going to make it a closed circle, because the y-intercept is 0, correct? We are going to go up, how far? 2 over 1.
2? We keep going?
Nah, we can just do a few and then draw a line through your point. Put some labels on this. Okay. I'm going to squeeze a 1 in here. How about this line? What's the y-intercept? -3, and it's got a slope of 1. Now, if we were going forward, we would go -3, and then we go up 1 over 1. Agreed? But we don't want to go forward, we want to go backwards, so we're going to have to backtrack. So here's -3. I'm going to make it open because of this. Okay. And normally if it had a slope of 1, look where my pen is, I'd be drawing it over here, but I don't want to draw it over here, I want to draw it over here, because I'm only doing it when x is less than 1. Or x is less than 0, sorry. So let's backtrack. Instead of going up 1, right 1, how could we backtrack? Down 1, but then also go left 1. Here's why this works. If I have a -1 over -1, isn't that still a slope of +1? So when I make the rise both negative, that's why it's... Okay, here we go. Backtrack. Down 1, left 1. We never go left, except when we're going backwards. Down 1, left 1. Down 1, left 1. Okay. So this one had 2 pieces.